Good morning, everybody, or good day to you, regardless of where you're joining us from. So very welcome on board to today's webinar. I'm very pleased to announce a nice initiative between Camden BRI and Biomeria. So just on the top, if I can perhaps introduce myself, and I shall just share my slides, if you can bear with me. So very warm welcome, everybody. Who am I? So today I am very pleased to be your moderator for today's webinar for the next hour or so. My name is Robert Butler, and I am marketing manager for Biomeria, all our food safety and quality diagnostics that we have at Biomeria. Based in Northern Europe and responsible for all of Northern Europe. And I am very pleased to welcome our guest speakers for today, Dr. Greg Jones and David Tomas from Spain. And today's webinar is essentially looking at various forms of requirements for the laboratory. Dr. Greg Jones will be taking us through the fundamentals of more traditional aspects, particularly ISO 7218, looking at how we get laboratories set up, calibrations, training, and that type of thing. And indeed, we will segue nicely onto David, who will take us through rather more alternative methods, rapid methodologies, the types of things that you might want to consider and should be thinking about if you're looking to adopt alternative methods, and indeed the basics around things like ISO 16140 Part 2 and some other things that you should consider. So who are these gentlemen indeed? So first up will be Dr. Greg Jones. He is microbiology training specialist at Camden BRI. I've known him for a number of years indeed, and he comes with a wealth of experience in the food and drinks industry, PhD in molecular biology from Swansea, over 18 years, it seems, running research projects for the food and drink industry. And indeed, I've seen several of his presentations on next generation sequencing, and I can indeed attest to his expertise in there. And that last point is very interesting to me. It seems Greg is a Python wrestler, from what I can establish. No, using Python and R, which I believe are programming formats for data analysis and that type of thing. So very much on brand for the future of how we work in the food industry and managing data and the challenges thusly. And indeed, also to introduce David Tomas. He is our Global Scientific Affairs Director at Biomeria, based in Spain, and has, again, a wealth of experience working with various standardization and ISO norm organizations within the food industry, a member of the Research Institute for Food Engineering, and indeed has a good history as senior scientist at Nestle Research and manager at Spain. So a very warm welcome to you, gentlemen. I think for you guys in the audience, hopefully for the next 50 minutes or so, we'll be presenting to you, first Greg and then David. If you have any questions, I will please invite you to use the question panel, which hopefully you will see in the top right-hand corner of your screen. I think it's a little text box with a question mark in it. Please do submit your questions as we go, and we will do our best to assign those to the appropriate panelist. And at the end, after both speakers have finished their presentations, we will have a quick question and answer session. And indeed, any questions that we don't manage to address, we'll be sure to make sure we follow up with you accordingly. So with that in mind, I propose we press on. So Dr. Greg Jones, perhaps you have something to discuss with us on ISO 7218 and traditional methods.
Certainly do. Thank you, Rob. Thank you. Right. Now, may I just confirm that my screen is being shared?
I can indeed see your screen, Greg.
Excellent. Well, thank you. And thank you for the introduction there, Rob. That was very kind of you. Thank you. Okay, here we are, ISO 7218 2007. So what we're going to cover in this particular little session, ladies and gentlemen, is we're really going to run through this standard. we're going to have a look at the whole thing. But what we are going to spend most of our time on is looking at how results are calculated using your sort of traditional plate counting methods. So we're going to take a little look through through some of the mathematics of how that is achieved. But I said we're going to have a look at the whole standard, and I'll confess that I am feeling a little nervous doing this because the chap who wrote it is David. And so if I manage to get something completely and utterly wrong, I'm sure he will step in and tell me how wrong I am. But here we go. Let's start off and have a look at the standard itself. So what does this standard contain? Well, the title of it there is fairly self-explanatory, hopefully. Microbiology of food and animal feeding stuffs, general requirements and guidance for microbiological examinations. So what does it have in it? It's got the requirements for laboratory equipment, personnel and premises. It has requirements for preparation of media and preparation of samples. And it has requirements for enumeration, detection, and confirmation of organisms. And like I said, it's that enumeration piece we're going to sort of dwell on a little more in a few slides' time. Okay, so let's take a look at what's in the standard. So sections 1 and 2. Let's start off, and I think that really the scope of the standard is very much pertinent to the theme of today's webinar. So the purpose of this international standard is to help ensure the validity of food microbiology examinations, to assist in ensuring that general techniques used for conducting these examinations are the same in all laboratories, to help achieve homogeneous results in different laboratories, and to contribute towards the safety of the laboratory personnel by preventing risks of infection. So essentially, the standard is there to make sure that results from different laboratories are the same, and that when you get them, you are doing that in a safe and as standardized a manner as possible. Section 2 are your references for the standard. And then we move on to section number 3, which is all about the premises. So we talk about safety, and in there we have definitions of the risk categories of organisms. We look at laboratory areas. So that defines the areas of laboratories that contain specific activities and which should be separated from each other. So for example, you don't want to be preparing your samples in the same place that you are counting your plates because of the risk of cross-contamination from one to the other. We also have guidance there on layout and fittings. So that is guidelines for the construction and quality of a laboratory to ensure comparative methodology is achieved between facilities. And then we have points to consider when choosing cleaning and disinfection strategies as well. So we need to be thinking about what chemicals we use, how we structure our cleaning regime as well. Okay, moving on then to section number 4, we can talk about our staff. So here we are looking at the competence and verification of that competence. So here we look at guidance on the methodologies to follow to prove staff confidence. And we also have a little section on proficiency schemes as well. So in order to make sure that your laboratory is functioning correctly, then your staff need to be standardized as well as your equipment and facilities. And there's also a section there on hygiene, so guidance on the measures to take in order to enforce hygienic practice among staff handling samples and organisms as well. Okay. Section 5, well, Section 5 is brilliant if you are just about to start equipping a microbiology laboratory, because you've essentially got a list of equipment there, which is what you need in that laboratory. So I don't propose to go through that list you see on the right-hand side of the slide there in a huge amount of detail, but just rest assured that if I was going to be setting up a microbiology laboratory, I would probably have one at least of each of those things in there. Each piece of kit which you see there, each piece of equipment, has advice on its description, its use, its calibration, its verification, its cleaning, and also its maintenance. Okay, so we've got our laboratory set up. We know that we've got staff in there. We know how to train them. We know that we're operating to a good hygienic standard. What next? Well, we've got to start getting into our actual operation of the lab as well. So section 6 tells us all about preparation of glassware and other laboratory materials as well. So that covers the sterilization of laboratory glassware, preparation of disposable materials, decontamination of reusable materials, and very importantly, decontamination and management of waste. You do not want pathogens leaving your laboratory, for example. You want to decontaminate that waste before it leaves the laboratory. And then we're also talking about preparation of culture media, but this standard doesn't cover that. What we need for that is ISO 11133, which covers the preparation of culture media and what to use when. Okay, so we know we can operate our laboratory. We know that when we've got our glassware and media prepared, the next thing we need to do is to get a sample to it to be able to process it. So section 8 covers exactly that. So it covers sample handling, it covers sample storage, it covers receipt, it covers transport, and the test portion is covered by ISO 6887, which is essentially the preparation of the bit of that sample which you are going to look at. Section 9, examination. Well, this here talks about hygienic precautions and how to prepare the initial suspension and subsequent dilutions of that sample. Okay, so we've got ourselves a laboratory, we set it up, we've got to the point where we've got all our laboratory glassware and all our culture media has been prepared properly. And now we are at the point where we're examining a sample itself. So what we really want to be able to do, the reason why we've got our laboratory set up the way we have and trained the people the way we have and all the rest of it, is we want to get to this enumeration part here. So when we get to methodology for plating samples, this is really a little summary of how it's done. So what we do is we take our appropriate sample portion, for example, 10 grams worth of sample. We then blend it in a diluent to achieve a 1 in 10 dilution. And after that, we prepare further dilutions, each of those more dilute than the previous one. We add that to our solid agar media and incubate for the designated combination of time and temperature. And then after that, we count the resulting colonies and calculate the results. Okay. This section here is the really tricky one. This is the preparing further dilutions, each 10 times more dilute than the previous one. But which dilutions do we choose? Which ones are we going to choose in order to be able to get to the correct dilution, the one that we want? Well, if we have some previous experience, that's really going to help inform us here. So the knowledge of previous or similar examples will help decide which dilutions we are going to use. Of course, if you are approaching a sample completely cold and you have no prior knowledge, then you are going to go for a fairly wide spread of dilutions in order to capture the information that you need in order to be able to hit the right range of microorganisms. Okay, so let's have a look at enumeration using a solid medium. If we're using a single dilution, such as maybe a 10 to the minus 1 dilution, we use 2 plates of that dilution. If we are using 2 dilutions, such as a 10 to the minus 1 and a 10 to the minus 2, we can use 1 plate of each dilution. Okay, great. So if we are then examining our test sample, or indeed our initial dilution, 1 milliliter of our dilution can be spread across 3 plates. Okay, great. So that tells us how we can sort of do our dilution. So we can go with 1 dilution and use 2 plates. We can set up our series of dilutions. So we can look at 1 plate of each dilution, which gives us the right number of colonies, or we can spread our first dilution or our test sample across 3 plates. How many colonies is the right number of colonies? That's the next question. Well, for a total colony count, your limit is up to 300 per plate, and we're talking here about a 90 millimeter diameter Petri dish. If we are looking at typical and presumptive count, so that's where we're using the morphology of the colony to give us some information, the limit is up to 150 per plate. And again, that's a 90 millimeter Petri dish. Okay, So we've got our colonies on our plates and we've counted them. What do we do next? Well, this is where we need to calculate our results. So
Greg,
calculation and hello, sorry, Rob. Yes, did I miss a poll? I'm pretty sure I did
do
there,
we have
didn't
a
I?
poll? I wonder. I think we might have a poll, perhaps something
We are on
for our
slide 11. We
audience.
are, yes, absolutely, Rob. I apologize completely. Let's put the poll up and see what we
Not
can
at
get.
all. So hopefully you guys in the audience, a little question for you. So are you using single dilutions or multiple dilutions in your laboratories? So hopefully relatively straightforward, just to warm you up today. It's a simple yes or no, and we can see the answers coming in live. We'll just give people a few questions just to decide on their answer. We can see about 50%, about half of the audience have taken the plunge. I'm not sure it's a right or wrong, so
It isn't a
no
right
wrong
or a
answers.
wrong. We are just really. This is just information. It's just fascinating to see how people operate out in the wider world. You know.
Absolutely. So I think probably we're coming up to about a minute there for that poll. If we can perhaps close that one out. So poll has ended. And okay, so we're a reasonable split. So about a third to two-thirds split there for single dilution versus multiple dilutions.
Well, that's fascinating. Yeah.
Oh,
How about that? Thank you,
very
everyone who voted there. That's really very interesting, if I'm honest with you. Okay. Right. Let's bring myself back to where I need to be. So there we go. Okay, so after we have used our plates and we've counted our colonies, assuming we've got the right number of colonies on the plates, we then need to calculate and express our results. And so here we're looking at section 10.3 of our standard, which is calculation and expression of results obtained with solid media. And so the principle behind it is this. First of all, we calculate a weighted mean. Then we simply back calculate the initial concentration of organisms by applying the inverse of the dilution factor. What? Okay, let's go through exactly what that means. Let's walk us through it. So here is our formula from ISO 7218. And the thing we are really after is this thing here, big N. So big N is our result in colony forming units per gram. That's what we're trying to calculate. Okay, now we've inoculated our plate with a certain amount of inoculum. So where does that come into this formula? Well, that is this big V here. So that is our volume of inoculum per plate in milliliters. If we're doing something like a total viable count plate, that is probably going to be 1 milliliter. So that makes the maths a little easier. Okay, we counted our plates and we have more than one. We're assuming here we've got more than one. We've got a dilution which is 10 times higher than the next dilution, and we're counting both plates there. So what do we need to do? Well, we need to count our colonies, and that's what this little fella up here is all about. So that's the sum of C. So that is the sum of the colonies from both dilutions. Okay. Now I've mentioned 10 to the minus 1, 10 to the minus 2, something like that. Where does that come in? Well, it'd be no surprise to learn that that is this little chap down here, this small d, and that is our dilution. All right, so let's just walk ourselves through an example of this so that we don't feel too scared about what's going on. So we're looking here at the sum of C. How do we get to the sum of C in this case? So let's stick with our example of plate count agar using 1 plate per dilution. So we've got a dilution series, and I've counted 1 plate per dilution. I've inoculated each Petri dish with 1 milliliter of each dilution as well. So I've counted 45 colonies on my 10 to the minus 1 plate and 5 colonies on my 10 to the minus 2 plate. Okay. So to calculate the weighted mean, these two numbers are added together, then divided by 1.1. So let's do that. So sum of C is 45 plus 5, which is equal to 50. Then to get my weighted mean, I divide 50 by 1.1, and that gives me 45.45 recurring. And that 45.45 recurring is my weighted mean. Okay, that's not the answer, because we then need to look at the inverse of the dilution factor. So that is where that small d comes in. So the dilution factor refers to 10 to the minus 1, 10 to the minus 2 on our agar plates on our dilution. So the inverse of the dilution factor, okay, so let's see. 10 to the minus 1 is equal to 0.1, okay? And so the inverse of that is 1 over 0.1. So let's see what we get with that. So 1 over 0.1 is equal to 10. So then we multiply our weighted mean by the inverse of our dilution factor. So that's 10. So we multiply 10 by 45.45, which gives us 454.54545454545. And the standard asks us to round that to two significant figures. So that is 450 colony forming units per gram. How about that? Great. So that is sort of when everything works properly. There are, unfortunately, some limitations to this. So our limitations are laid out in ISO 14461-2, which specifies the upper and lower limits for numbers of colonies on each dilution. And Rob, I do believe we've got a poll here. So I think this might be the point to pop that in, if that's okay.
Very correct indeed. So the question is for our intrepid audience, are you using the tables of limits in ISO 14461 Part 2? Cast your votes, please. I feel a little bit like I'm in the presenter of the Crystal Maze.
Left a bit,
There's
right
no
a bit.
automatic lock-in though, so don't panic. And if you're old enough to understand that reference, well, we'll say no more.
Oh, well, thank you for that, Rob. I obviously am old enough to understand that reference.
Indeed. But I've betrayed myself, obviously. So. Just a few more seconds for any final votes. About half of the votes, half the people voting. Perhaps we should also have the countdown music. Again, that's a
We
very
should, shouldn't we?
culturally specific reference there.
It is.
And if we could end the poll there, please. So finally, so 22% are yes and 78%, rather overwhelmingly, a no.
Well, how about that? How very interesting. So I think there might be a little work there to see how we make those limits better known. Let's put it that way. Okay, let's move back to where I need to be. And here we go. Okay, so we know that there's some upper and lower limits for the number of colonies in each dilution. A few of you are familiar with these, but it would appear that there's a number of you out there who are not. So let's see what we should be doing. Okay, so for a decimal dilution series, so that's 10 to the power minus x, D1, so our first dilution should be 10 times larger than D2. I'm assuming everybody has figured that out. That's why we call it a decimal dilution series. And if the dilutions don't follow this expectation, then there is the limits in ISO 14461-2 should be applied as well. Okay, so if we look at these limits, what are we trying to do? So on our first dilution here, so 10 to the x, so might want to call that 10 to the minus 1. We've got our observed count here. So let's pretend we've seen 93 colonies on our first dilution, on our 10 to the minus 1. On our next dilution down, so 10 to the minus 2, so 10 to the minus x plus 1 on this table here. So if that was 10 to the minus 1, this would be 10 to the minus 2. We actually have some limits. Well, we're expecting to see a count of 9.3 colonies on 10 to the minus 2. You're never going to find 9.3 colonies on a plate, because how do you count 0.3 of a colony? That is just essentially our calculated expected value. Here we have upper and lower limits for what is acceptable on that lower dilution. If your count is outside of those limits, then you can't use that plate in your calculations. That's essentially what this is saying. So it's important to be able to apply these limits, because otherwise you are actually outside of what is accountable. There are parallel plates, ISO counting a single dilution using 2 plates, and that is also specified in ISO 14461-2, and it also comes into the annex of this standard as well. So we will have a brief look at that a little later on, so don't panic for when we get there. Okay. What happens in situations where we have plates with less than 10 colonies? Right. Well, accuracy decreases dramatically below 10 colonies per plates. So what is the lowest number of colonies that can be used for an enumeration? Well, once again, we need to bring in another ISO document. So this one is number 13843. And in it, the lowest average particle concentration X per analytical portion where the expected relative standard uncertainty equals a specified value, the RSD, is defined. Okay, well, that was a bit of a mouthful. And just to make it even more complicated, today we use the term coefficient of variation rather than RSD. And coefficient of variation is abbreviated to C underscore V, or to C subscript V, should I say, instead of RSD. Okay. This next slide is a little background on exactly where we get CV from. So where we get the coefficient of variation from. So let's just go through this quickly. So the coefficient of variation assumes a Poisson distribution. That is where the probability of finding a low number of colonies on a given plate is quite high, and the probability of finding a high number of colonies on a given plate is quite low. So that's essentially the probability of finding a low number of colonies, and your distribution will look like that. The standard deviation in a situation like this is defined as S, and that is equal to the square root of the mean. Okay, CV is our standard deviation divided by the mean, and our lowest average particle concentration, so X, is equal to 1 over CV squared. Right, okay. Now, there's not going to be an exam on this at the end, and in fact, the ISO standard we're looking at does make things a little bit easier for everyone. So what does all this mean in practical terms? Well, ISO 7218 sets CV at 0.5 with a justification attached to that it seems to be reasonable in microbiology. Okay, that's so that takes a lot of that work out. You don't have to think too hard about this slide because ISO 7218 has been very kind to us and sets CV at 0.5. Our ISO standard, which sets X, is equal to is per analytical portion where the expected relative standard uncertainty equals a specified value, and a plate to 4 to 10 colonies can be used to enumerate, with the result being labelled E for estimated, and a plate with 0 to 3 colonies is reported as presence, also quoting the limit for enumeration. Where does this come from then? Where does 4 to 10 or 0 to 3 come from? How does that work? Well, if we think about X, so that's X here, we are talking that is 1 over CV squared. Well, we've set CV to be 0.5. So X is 1 over 0.5 squared, which means X is 1 over 0.25, so X is equal to 4. That's where our limits come in here for 4 to 10 versus 0 to 3 colonies. So what's that mean in practical terms again? What does that actually look like when we're counting plates? So here's an example. Here we've got our dilution factors, 10 to the minus 1, 10 to the minus 2. We have counted 5 colonies on our 10 to the minus 1 plate, and we've used 1 mil to inoculate each plate, or 1 mil per plate, should I say. Okay, so we've counted 5 colonies on our 10 to the power minus 1 plate, and that is our C. 5 is larger than 4. There we go. Thrill a minute this, isn't it? Then, so we can calculate our estimated count using the formula C over VD. Okay, so what does that mean? That means our estimated count is our 5 colonies divided by 1 volume. So our volume is 1 times 10 to the minus 1, and that's our D there. Okay. So our estimated count is 5 over 0.1. So we report our estimated count as 50 colony forming units per gram. Great. Okay. What happens then if we have a situation like this? I've only got 3 colonies on my 10 to the minus 1 plate. Okay, so C is equal to 3, and that is less than 4. So what do we do there? Okay, we say the microorganisms are present, but less than 4 over VD per gram. So microorganisms are present, but less than 4 over 1 times 0.1. So therefore, microorganisms are present, but are less than 40 per gram is how you would report that. Now, of course, I've picked the easy ones to do the examples on. The standard does cover other situations. So we'll just have a quick run through what those situations are and how you would then report it. So if you're in a situation like this, so here we've got our first dilution, our second dilution, we're talking at less than 1 over V2 D2 and more than 1 over V1 D1 microorganisms per gram. We've got another situation here where we are under 300 typical each time, and we can use this reporting structure for the reporting. And again, we can look at what happens when we're outside confidence limits. So that would be unacceptable if you remember back to our table. If we're within our confident limits, then we calculate as per 10.3.2.2 of this standard. Further cases, we can look at using the estimated count using D2 in this situation. This one, again, we're outside our confident limits, so we're unacceptable. And here we would say we're at more than 300 of this dilution here. Okay, what I would recommend is getting hold of a copy of the standard and having a look at that. So, I mean, it would be utterly flattering to think of people relying on this presentation, but I wouldn't recommend it. I would look at the standard itself. So do look at the standard itself and make sure you're looking at the latest version of it. And I'm sure David will have something to say about the latest version of it coming up as well. I believe there is a calculator, which sounds very exciting, which I'm sure David will mention in his preamble to the next session, hopefully. Okay, so let's take a look at a little example then. So plate 1, we've got over 300 colonies, some of which are typical or confirmed. Plate 2 has over 300 colonies, none of which are typical or confirmed. Okay, so we report this then as less than 1 over V2 D2 and more than 1 over V1 D1 microorganisms per gram. So for example, plate 1 is equal to a 10 to the minus 3 dilution, plate 2 is a 10 to the minus 4, and we're using our 1 mil inoculum. So our report comes out at less than 10,000, more than 1,000 microorganisms per gram. Okay. You might be relieved to know that we have just swerved away now from the calculations, and we're just going to have a look at the rest of the standard. So the later sections of the standard, section 10.5, we look at enumeration using liquid medium and the most probable number method. We haven't even touched on most probable number, and I think there's about 4 days worth of most probable number calculation that we could be looking at there. So it would be probably beyond the limits of this webinar to get into that. But again, a fascinating read if you have the urge to read it, or if you are doing MPN, then do look it up. Section 11 looks at detection, so the qualitative methods. Section 12 looks at confirmation. Section 13 talks about reporting. Section 14, validation of microbiological methods. I'm sure we're going to hear a little more about that. And section 15, we get the QA of results, the quality assurance and quality control of performance as well. Okay, well, unfortunately, back to calculation. So this sits in the annexes. So the annexes, A is about properties of disinfectants. B, we're looking at confidence intervals for the colony count technique. Annex C, we're looking again at determination of most probable number. And then we've got Annex D, counting of colonies with 2 dishes per dilution. And I mentioned this earlier, but don't panic. Don't panic about what's coming next, because it looks horrid, but it's not. So we're looking at counting of colonies with 2 dishes per dilution, and this formula here is given for that. Now, this is just a version of the formula we saw earlier on, the only difference being that we've got a little bit more down here, and probably the best way of looking at this is using an example. So we will jump over this for the moment and take a look at the example. Just also to mention, as I did before, that there are limits for the ratio of the colonies between the first dish and the colony count of the second dish, and that ratio should be equal to 1. And again, there's some limits here which must be applied to those to that situation there. Okay, let's take a look at our example then. So here we've got two dilutions. We've got D1 and D2, and we've got 2 plates per dilution. D1 is a 10 to the power minus 2 dilution. D2 is a 10 to the power minus 3 dilutions. And we've counted 168 colonies there, 215 there, 14 on here, and 25 on there. Right, so where do we plug all these numbers into? Well, our sum of C is add up all those numbers on the plates, add up all our colony counts. Okay. Our volume for each one of these plates we've inoculated with 1 mil, so that stays at 1. N1 is the number of plates on our first set of dilutions, that's 2, plus, again, N2 is 2, so again we've used 2 plates here, and we've got our 0.1, which is our constant in here, and multiply that then by our initial dilution factor. So if we work all that out, we've got N is equal to 422 over 0.022, which is approximately, what's that? That's 1.9 times 10 to the 4 CFU per gram. And that is all I really have to say on this in the interest of keeping to time. So our take-home messages from this then is that ISO 7218 covers the facilities, equipment, people and methodology to use when examining foods and feeds for microorganisms. What it doesn't do is give specific methods for individual organisms. It does, however, give guidance for the use of traditional agar-based counts, as well as the advice for MPN. So I didn't talk about that at all today, but it is in there if you are operating an MPN-based system. Alternative counting methods should be validated using ISO 16140 Part 2. But I shall leave it to David to give us a bit more on that in a moment or two. But otherwise, thank you very, very much for listening, everyone. And I'm going to do my very best to stop sharing here. So there we go. Has that achieved itself?
I believe it has.
Hey, look at that. The
Wonderful.
system works.
Technology does have its moments, I guess.
Doesn't it just, eh?
That was wonderful. Thank you very much, Greg. And that was a beautiful segue for David, who will now take the floor, speaking on alternative and rapid methods, and perhaps a bit about validation and verification indeed, as you mentioned, around ISO 16140 and its various parts, particularly part 2 perhaps. So, David, I think in the interest of time, we may be running a little short on time for questions at the end. So we possibly may run a little bit long, a little bit over 11 o'clock for UK and 12 o'clock midday for our European guests. So for anybody that is able to stay a little longer, we will invite you to maintain the webinar just for a few minutes extra, just to treat those questions and answers. And if not, if you do have to dive off on the hour, we understand, of course, and you will have the recording available to you to review. So with that in mind, David, I invite you to take the stage.
Hello, thank you. Can you see my screen with the presentation mode?
Very clear.
Okay, perfect. So let's take the rest of the hour to speak about alternative methods and the application of standards for the use of those alternative methods. So I'm going to explain why to choose alternative method instead of the reference method and how these alternative methods should be validated. And also I will include some words about other standards that are applicable if you are using alternative methods based on molecular techniques. So why alternative methods? And this brings me to the previous presentation around the ISO standard. So to have an alternative method, of course, we need a reference method, and the reference method could be the ISO standard or could be other official standards. But let's take the ISO standard as the reference method, and then the ISO 7218 is applicable to both reference and alternative methods. And going to the point of the 7218, just to tell you that we are currently finishing the new version that will be released this year, probably about summertime, but Q2 or Q3 of 2024. And we try to simplify the expression of results part, and including also an Excel tool that will be free available in the ISO website, and you can download it. And this website Excel tool will give you also the results and also the confidence intervals about the different Petri dishes or the different dilutions, as Greg mentioned before. So don't worry, the new standard, we will try to simplify and also to give you tools to use in your routine analysis. So let's go for the alternative method. So why alternative method if I have a reference method? Well, usually I try to explain we are in an Olympic year. So this year the Olympic Games will be this summer in Paris. Unfortunately, not in Madrid, or maybe fortunately not in Madrid, in Spain. And you know that the Olympic Games follow a logo saying Citius, Altius, and Fortius, that translated is faster, higher, and stronger. Well, why to use alternative methods? First, because usually they are faster. So if you follow the, for example, for Listeria monocytogenes, the ISO standard, the negative result will take around 4 days. But using, for example, a molecular method, you can have a negative result in 24 hours. So that's one of the benefits from using alternative methods, and because that are used in the food industry. We don't have higher and stronger, but we want to have it simpler. So on the left, you can see some Petri dishes with Palcam or Aloha agar. When you can identify, again, I take the samples of Listeria monocytogenes, and you can see that usually those pictures are not in the brochures, are real pictures that I took a few weeks ago. And you can see how variable and how difficult could be to find a single colony in such a big background flora. So it's not easy, and you need to have experienced people doing that, and you need to have also to take a number of colonies to be confirmed depending on what are you finding on such plates. On the right, you can see what is a typical setup of a PCR method, that you can have positive, negative, and also you will have the internal control saying the internal control is correct or not. So with this alternative method, usually you should have a very, very simple reply, a very, very simple position to take actions or not. And then instead of stronger, I would say easier. So on the left side, you can see the number of tubes and Petri dishes that you need to perform 100 samples when using the ISO standard. So you need to do the secondary enrichment, you need to do the isolation. So you need to use a big number of material, incubator size, and also manipulation of culture media. On the right, you have a box containing 100 tests for salmonella detection. So in a very, very small box, you can have all the same that you have on the left. So it's easy to use in a quality control laboratory. You have also, of course, a number of technologies available. So you can use, because I talk about molecular methods, but alternative methods are also based on cultural. We have chromogenic media that you can use for enumeration, or you can have also automated, most probably number-based systems like this system used for enumeration. And also other technologies like the immunoassay, like the VIDAS, flow cytometry, for example, for commercial sterility, or even new technologies like mass spectrometry for colony identification and confirmation. So there is a number of technologies that you can use for application of alternative methods, making your life easier. However, as always, we have some limitations. So to implement a new technology, you need to work differently in your lab. You need to find new ways of working, and the setup in your lab maybe can change to improve your performance. Then also you might have to do an initial investment in equipment, because new technologies are usually an alternative method, are in most of the case based on equipment. And also those technologies are proprietary. So the company who develops the technology submit a patent to avoid that other companies are making benefit from that. So this means that usually when you implement an alternative method, you go for a single supplier. And the most important is that the results must be equivalent to the reference method. So this requires validation. And that's the point that I'm going to develop during my presentation. So we need to demonstrate that our alternative method is equivalent. And in some countries, for example, in the European Union, we have this by regulation. So the European Union regulation requires to do a validation in certain aspects. So I'm going to develop this more. So regarding the validation, we would like to do a poll to understand if you are using alternative methods in your lab. So maybe you can launch the poll.
Yeah, look, the poll is live. So indeed, the question is, are you familiar with alternative methods? Options being, I'm not using alternative methods. I use alternative methods, but unclear if they have been validated. And the final one, yes, I use alternative methods and am convinced that they are indeed correctly validated. So just a few questions perhaps for people just to cast their final votes.
I cannot see the results, Rob, so if you can.
Don't you worry, no, I'll
when
talk
finished.
you through it. No, no problem at all. If we can end the poll there, please. So overall, half of the people, yes, using alternative methods and know that they're validated. About a third of the people are not using any alternative methods. So I guess sticking to traditional and culture, and using alternative methods, but unsure if they're validated, in the minority at 13%.
Okay, good to know, because
Thank you, Rob.
I'm going to explain what important is the validation and how can you take the benefit from the validation reports in a few slides to be able to take the benefit on that part. So I think most of the people will be interested in the next slides. Then I need to introduce the ISO 16140 series. Unfortunately, it's not a single standard, but it's a series. So starting by 1, that is the vocabulary, then 2 and 3 I will explain you later on, and then we can continue by the part 4, 5, and 6 that are the currently published. So the last one was 2020. So we have 6 parts published of these validation standards. And then we are working at ISO level on the part 7, 8, and 9 that will be a different protocols and very different approaches. So I don't want to spend a lot of time on that. Just let you know that you have a number of series of different applications that are focusing on different needs. That's like Game of Thrones. So we have a lot of seasons, and I hope with the 9 will be finished, but you never know, because the 9 is covering toxins, we cover viruses, parasites, and also different validation for single laboratory or for organization of interlaboratory. So in my opinion, this is covering almost everything that you can need, but you never know. For the moment, 9 parts are planned and 6 are published. And let's go for the 2 and 3 that are, in my opinion, the most relevant for the alternative method. So the part 2 is the protocol for the validation of alternative methods, usually proprietary, and we always need a reference method to be validated against. And we also have the part 3, that is the protocol for verification of the reference and validated alternative methods. So part 3, it's applicable for both, for the reference methods, but also for the alternative validated methods. So you should use the 3. And let me just put one slide to explain you what are the difference between part 2 and part 3 with a totally non-microbiological example. That is the car example. I use this example because I think it's very visual. So the part 2 are all the tests that the manufacturer is doing to demonstrate that the method works well. It's like all the tests, the security test, the environmental test, the stability test that a car manufacturer is doing. Well, we, the manufacturer of the methods, are doing that. So we do a number of tests to demonstrate that the method works well and is equivalent to the reference method. However, the part 3 is not going in that direction. It's going in the direction that you, the laboratory user, are the driver of the car. So you need to take your drive license. And that's the part 3, is to demonstrate that you are able to implement and to use correctly the method. So you don't need to validate an already validated method. You just need to know how to use this method in a normal condition, but also in some difficult conditions. And because that, the ISO standard includes 2 steps, that is the method implementation and the food item verification. So again, this presentation is not going in that direction, but I just would like to clarify what is included in the part 2 for the manufacturers, and always demonstrating that the method is valid. And then the part 3 is for you, for the user, to demonstrate that you can perform the method correctly, not to demonstrate that the method is valid. Okay? So how the method is validated? Well, we perform a number of tests that are fully described in the part 2 of the method validation. So this standard includes what should be done to demonstrate that the method is equivalent. And again, according to the European Union regulation, you need to do this validation following this standard. You cannot use another validation scheme. So you need to follow this, and you can see that we have quantitative and qualitative validation, and usually are included 2 different steps. One is the intra-laboratory, so all this study is performed by an expert lab. And then you have a second step, that is the inter-laboratory study, when you need from 8 to 10 laboratories minimum. Usually we use 15 to 20 to perform the test with samples, with contamination levels, and to demonstrate that the method works well in different conditions, different laboratories, different countries, and different facilities. So this is required to demonstrate that an alternative method is equivalent to the reference method. I'm not going to tell you about the details, but if you have questions, of course, happy to reply you. And then also, the European Union requires not only to be validated according to this method, but also to be certified. And there are some independent organizations that, like AFNOR validation, like Microval or Norval. You have here the links if you want a certification scheme to demonstrate and to put in value all this validation and to release a certificate of analysis. So at the end, in those websites, you can find all certificates and, more important, all the validation reports. All validation reports are public. You can access to all validation reports from all suppliers that are certified. So let's go a little bit in detail about the certificate and the validation report. This is how looks like a certification report. On the left from AFNOR, on the right from Microval, and then you can see that it includes the name of the alternative method. This is an enumeration method for enterobacteria, and this is a detection method for cigatoxin E. coli. This is based on cultural, on most probably number, and this molecular method, it's a PCR method. And then you need to check some of the important points on the certificate. First, that the certificate is renewed every 4 years. So every 4 years, the certification body is going to check if the certification is still valid. So you have it here or here. So both are still valid, but maybe that are not renewed. So you need to check in your documentation plan that it's still valid. And then you need to check what is the reference method that is validated against. So you can see that this is validated against the ISO 13136, and this is validated against the ISO 212528. So these 2 references are showing that your method is equivalent to those methods. And then you need to check the scope. Which matrices are included? You can have a method validated for all human food products and pet food, for example. And here you can have a limited scope. You don't have a broad, all human food products, but raw meat, raw milk cheeses, and environmental samples, for example, for cigatoxin E. coli. So then if there are restrictions, also are highlighted in the certificate. So the certificate is giving you the validity and the equivalence of the method. And then also added to the certificate in the website, you can find the validation report. So what is a validation report? That's the first page of the validation report, and then you have a summary report. For example, in this case, it's an immunotest, VIDAS, easy salmonella for detection of salmonella. And that is the validation report. And you can see that in this case, the validation report includes 124 pages. So I'm not going to say you, please go to the 124 pages to check the report. I can see that it's a very heavy task, and then it's not easy to go. So I will try to summarize in only one slide. Again, you can, all the report is available for you, but in one slide, I'm trying to give you the important values. So from those reports, there are two tables that for me are very relevant. Not always is the table 6 and the 14. It depends on the report, but it's the table including the sensitivity study summary. And then you can see that there are formulas. Again, we are using formulas, but that are very easy. All the formulas are estimated in the report, and you have values. So with the sensitivity, you can understand what is the consumer risk or the food safety associated to this method. So, of course, the values has been already evaluated by the technical committee on the certification body to demonstrate that the method is equivalent. So statistically, there are no differences between 99.3 and 97.2. So, but those values are showing that what is the probability to detect a positive sample. So you have more than 95% in both cases and equivalence between both. So sensitivity is the probability to detect your target, in this case, salmonella. And then you have also the false positive ratio. That's not linked to the food safety, it's linked to the consumer risks. Why? Sorry, to the producer risk. It's a cost for the producer. Because in this case, you have 0, meaning that all the samples that are positive for the alternative method are real positives. But may happen, depends on the alternative method, that you have here a number of false positives. If the number is very high, this means that you will have a lot of positive results that are not really positive. You will have a percentage of samples that will give you salmonella positive, but that's really not salmonella. And then it's a producer risk because you can retain your batch, you can take actions that are not needed because the sample is not positive. Okay, so again, this is acceptable. You can have a number because at the end, this is not impacting the food safety, but you need to check that this is not too high or is acceptable for you. Okay, there is not an acceptance value, but 0, 1, 2 may be acceptable, 50% may be not acceptable for you because this means that 0.5% of the cases you will have to confirm and will be negative. And then another table, important table, is the limit of detection. So again, the values has been already evaluated by the technical board, but you should use those values for an alternative method for your internal method verification. So remember that you have the ISO 61140 part 3 that you can use for method verification. And in this case, you need to use those values. Same for a enumeration. So for example, this is a report for microbial, but looking almost the same. In this case, 50 pages. And again, I summarize in two tables. The relative trueness table is giving you if your method is precise and accurate. So it's in this situation. Okay, so this green column is giving you if the method is accurate, is giving you the bias of your values. And the SD, the black, is giving you if your method is precise. So if it's reproducible. And then also the red columns are giving you the interval. So for example, for meat products, you can expect that your alternative method is giving you between 0.6 and 0.76 log values. Again, I'm not going to explain all the details, but this table is giving you this information about how precise and accurate is the method. And then the interlaboratory table, that is always like that. You can easily find this table in your validation report, will give you the reproducibility standard deviation, that those values are the values that you will need to use for method verification, for your internal method verification, to see if you have implemented correctly your method in your laboratory. So this is more or less a summary of what is method validation. And then we have a short poll around molecular methods. This is specifically for molecular methods. It will be few slides. Rob, if you can launch the poll quickly, and then
Certainly, yeah.
we will present few slides
Poll,
around molecular methods.
the poll is live. So do you use molecular methods for microbiological analyses? So options being no, and it isn't of interest to me at this time. No, but I am considering this. And the third one being, yes, we actively use this in the laboratory. So
if all results are first, we can stop here my presentation.
Don't worry, I can tell you there's still work to be done there on that side, David. So if we perhaps close the poll there, about 50% of people voting there. So nearly half of the people saying yes, actually we use it to some degree in the laboratory. Over a third of the people saying no, don't use it, but I'm interested in molecular technology, and nearly 20% people saying no, not at this time.
Okay, so let's, I think most of the audience is interested on molecular methods. So today we have an ISO standard, and of course, when you apply an alternative method based on molecular techniques on PCR, you should follow the recommendations and guidance and requirements included in this standard. So also one standard that is under revision. So this year will be published the next revision. So if you are going to buy it, please wait for a few months, because this revision will be new before end of the year. And this is the 22174 that is covering general requirements and definitions. But also we have another three that are requirements for sample preparation, for qualitative detection, requirement for amplification and detection, and requirement for real-time polymerase. Those are for PCR, and this is for real-time PCR, including general requirements and definitions. So as I told you, the new standard will be published this year, and this new standard will include those three. So don't buy these three today if you are not interested, because before end of the year will be not anymore available, because the new standard is integrating all these three standards. So will be published as 22174 2024. This is the last draft that we evaluated, and we'll be including those parts. So what is in this standard? So here on the left, on the light blue, you have all the parts that are included. So you have definition, sample management, enrichment and concentration, preparation of nucleic acid, the PCR amplification, detection and confirmation, laboratory environment, reagents, equipment, test report, performance and validation and verification. And in dark blue, what is new in this new part, if you already are using the 22174, just to tell you that for the new standard will be included also digital PCR, some requirements and recommendations for lab flow and environmental monitoring in a molecular lab, the extension of some controls from the PCR, and also quantitative evaluation. So these 5 bullet points are, I would say, the most new, and also, of course, some revision of the previous ones. And to finalize my presentation, just to remind you that also other standards are published. So you have also one standard for the thermocycler, so how to establish the performance of the thermal on the thermocycler. So it's a kind of calibration for accredited labs. And also you have the 231418 that is whole genome sequencing. So the general requirements and guidance for the application of whole genome sequencing. And that's all from my side. So here you have also my email, but I think we can open the Q&A session. and happy to reply. Thank you.
That is brilliant. Thank you very much indeed, David. Thank you for that. Very clear. And our apologies to everybody. We are running slightly over, but for those who are able to stay on, we would be very keen for you to participate to the question and answer session. So I see Greg is back on the forum here as well. So if it suits you both, gentlemen, I propose I'll take some of those questions and we'll pitch them to you for our discussion. And as we said earlier, any questions that aren't treated now, we'll be sure to come back to you and follow up either from Camden's side or indeed from biomeria's. So first one, and I'm coming out swinging here with this one, guys. This one is a little provocative, and in fact, I pitch it to both of you. The question is why is ISO still using plate methodology? So obviously, that's, I guess, referencing that culture has been around for a number of decades now as such, as a technology. Have we reached the stage where perhaps we're surpassing that and maybe transcending that as the reference method?
I can explain. So I think it was 15 years ago, we had a big debate at ISO level because we have one plenary meeting every year and we discuss all countries and we discuss about the practicability of the method. So we decided that the ISO method should be applicable with the low level of technology to do it accessible to all laboratories in all countries. So that's more or less why we still address also for detection methods the plate isolation, because we want to have accessible and to be available in all labs with the minimum technology required.
I'd agree with that there, David. I mean, there's also the sort of upfront cost of some of the alternative methods as well. So that would that can be a deterrent to a laboratory to adopt those methods in the first place, despite their advantages once you've got them.
No, I fully understand that. It certainly does make sense as I would say as a foundation, accessible to all and translatable to all. Okay, so another question
also
from...
should be, sorry, Rob, should be not based
please.
in a single supplier. So ISO method needs to have several suppliers to distribute the media, and then alternative methods are usually single supplier.
Yes, I think there is still that question of it as a universal language, let's say, from a microbiology perspective. That does still hold value, sure. Another question from Caroline Hiesman. So Greg, we've assigned that one to you, but perhaps for both. According to the standard 7218, it's recommended to store subsamples of all samples tested in its storage temperature until all results are reported. But it is not recommended to retest because of the change of microbiology status. So I guess the question is why bother? Where's the value in doing that?
I mean, I would say that is because in case you have any question over a detection of a pathogen, then that sample is available as a reference. I mean, I completely take the point that the microbiology is going to change over time if you're looking at a chilled sample or if you're looking at an ambient sample. However, again, if you are looking at a presence-absence result, I would say that it was useful to have that reference sample to go back to. I mean, David, what do you reckon?
Well, in the new standard, in the new revision, will be even stronger. So we say you cannot do it. It's not recommended not to retest. It's saying it's clearly if you have to retest, you need to clearly indicate that this is a retesting and it's something that you took from a sample already stored in your lab. And yes, I agree with you. So you need this sample in case that you have to do some contradictory analysis, but giving very clear in the report that this is a retest and it's not the original sample that you tested. And it's because that you sometimes you need to come back to the sample to really evaluate the status of the sample or really to have the sample. Today, I can see, I visited a lot of labs that are doing nice pictures and you have a very good recording of the sample. And sometimes if your agreement with the customer sending the sample is not required, it's not mandatory to keep the sample. It's a recommendation.
Very good. So another one, so it's not so much a question, more of a commentary perhaps from Per Nielsen. We have regarding ISO 14461 part 2, in some cases colonies may clog together and the high number may in fact underestimate the actual number of CFU. So I guess the point is therefore diluted plates may be more representative with that in mind, so you can prevent that, let's say, fusion of colonies, particularly for yeasts and molds. So I guess it's harking back, Greg, to perhaps the early part of your enumeration component of your presentation.
I mean, it's a common problem this that you do sometimes get clumping of colonies. So your accuracy does become less so. You are less accurate. I mean, I couldn't think of a better advert for alternative methods, to be honest with you here. So something that doesn't rely on a plate count. So yeah, it's a problem. I mean, what I would do personally in this situation is go with a count which I knew to be correct, if not as accurate as possible. So I would go with the lower dilution, and I'd apply the same the rules applied in 7218.
So with that in mind, on alternative methods, we have a question from Chris Edwards. So if I didn't want plates in an operational lab, what does 7218 look like then? And just for context, we're talking about yogurt and desserts manufacturing, high volume yogurts and desserts manufacturing, with a desire move towards full automation, AI for data analysis, and ideally with rapid release criteria, or even directly from the line potentially. So I don't know if that's sort of something we fall down the rabbit hole today, or if that is really just segueing. We're talking alternative methods ultimately, but perhaps your reflections, gentlemen.
That's the dream, isn't it? Isn't that the dream, is to be able to analyze 30 million pots of yogurt every week, or whatever it is, and get the results really, really quickly? I mean, we're not there yet. Absolutely, we're not as close to that as we'd like to be. But yes, alternative methods are getting there. We do have methodology which is a lot swifter than counting colonies on plates. Is 7218 the correct standard for those methods? That's the question. I guess, David, what do you think?
Well, I think the 7218 has some limitations, and in the scope you mentioned briefly the scope, and then it's described which kind of methods are applicable. So if you move away from the technologies that are applicable from the 7218, you need to use another criteria. For example, if you use flow cytometry or you use spectral vision, the standard is not anymore applicable, of course. And then you need to move to alternative methods to validate and to demonstrate equivalence, and then also to specific requirements if available, that not always are ISO developed.
Yeah, quite a deep one, that one, I think. Perhaps time for just one more question, perhaps for you, David. A quick question. Can I verify a non-validated method? So can I verify a method that is non-validated?
So today, an alternative method, not. So it's a requirement that if you are using alternative method, the alternative method must be validated. That's clear. Then going to the reference method, if your ISO method is not yet validated, and I say not yet because we at ISO level, we target to have it all methods validated, but it's not yet validated, then you have a document published in the ISO website saying that you still can verify your method. Again, ISO reference method, but you need to change a little bit the structure of the ISO 16140 part 3. So there are some limitations, but you still can verify a reference non-validated method.
Understood. Thank you very much. So everybody, I think in the interest of time, as we have run over there are a few more questions remaining, but I propose we treat those offline and follow up with you. It just rests perhaps for me to, I would say, close this webinar, to thank everybody for their attending and their participation in the polls and the questions and the discussion that has been associated with that. And indeed, of course, to thank our intrepid speakers, Greg and David. Thank you very much indeed for taking us through that. I would just like to say we will be submitting a survey. I think a survey prompt will probably pop up as soon as you close the webinar or as soon as you leave the webinar, but also you will perhaps receive that by email. We would very much like it if you could just take a couple of minutes to give us your feedback. Tell us what you liked and what you didn't like, as we are keen to be doing more of these things, and we would very much like to sculpt these around the needs as you see it in the audience. So if you have things that you think are covered and you'd like to know more about in more detail, or indeed if we were too detailed in certain areas and there are other things you think we could focus on, please do let us know, as we'd like to tailor those types of things moving forwards. So thank you very much for doing that. And if I can just indulge for one more moment, just an upcoming date that I think perhaps will be potentially of interest to people, if if everybody can see my screen. So another event where we are collaborating with our friends at Camden BRI in July. So hopefully you can see that in front of you. So Wednesday, 10th of July, we have an ultra processed food day. So that sounds, again, that's perhaps quite an alarming title there. But I think it will be interesting as we start to see these kind of ultra processed foods. And I think you will also be surprised at what is classified as an ultra processed food by today's standards, but also knowing some of the future technologies that are coming with alternate proteins, alternative meat sources, dairy, so let's say plant-based dairy alternatives and that type of thing. Perhaps looking at what we should be considering with these types of food, and perhaps what is the microbiological risk that can be associated to those. And indeed, the day after, as a double kind of tandem event on Thursday, 11th of July, Camden are holding a molecular day, so a seminar day focused on molecular methodologies, where bioMérieux will indeed be present and collaborating with them. So I will invite you, if you are interested in those, please do use those QR codes if you would like to try and register and have a closer look at the agendas. So with that in mind, unless there are any other final comments, I'd just like to give a very last and heartfelt thanks to our speakers, to our organisers, and indeed our audience. And with that in mind, I shall wish you all a very pleasant rest of the day. Thank you all.
Thank you very much.
Thank you, everyone.